Hello folks, my name is Rod McDonald. I'm one of the instructors in the summer school course. And there was a question placed on the discussion board, and basically it asked, what's the difference between stocks, flows, auxiliary variables, all these other variables in a model. So I thought I'd make a quick video and demonstrate what's going on. And stocks are accumulations in these systems that we're examining. So something that's accumulating could be either physical, it could be people, it could be money, it could be the number of cars, the number of parts, the number of tasks. They can be real things that are actually accumulating in our systems. Then we have to consider these, the conservation of mass with these. We talk about that, pretty sure it's module 4. And the other type of accumulation in these systems are information. And it could be morale in an organization is something that can go up or go down, right? It definitely has this idea of a direction that it can move and what more or less actually means. I don't know what the units of morale are. You could count them as morale units, but what's it mean to have twice as many morale units? I don't really know, but I know that if morale is high, that things in an organization are probably going to be better than if morale was low. So it definitely has that sense of up or down and what more means and what less means. So again, two types of stocks. One is going to be the accumulation of physical things, and the other could be the accumulation of information. Regardless, stocks are accumulations, and the only thing that can make a stock go up or down is a flow. So, and that's really a rate variable is the other way to refer to this. And I'm going to just start building a very simple model. And I'm going to click up, and I'm using Vensim. And I'm using Vensim DSS because that's what I have. I'm going to go up and click on the stock. I'm going to come down to the middle, and I'm just going to name this population. And because I've clicked on a stock, the icon, I'll click up here on this move or this hand, it typically comes out as a rectangle. So visually, any rectangles in our systems represent stocks. The only thing that I said can change a stock is going to be an inflow or an outflow. So I'm going to go up and click on the flow here. And I'm going to click to the left. And I'm going to go and I want to make sure I'm right on the stock. And I'm going to click again. And this is going to be my births. And then I'm going to click on the stock of population and drag it to the right. And this is going to be my deaths. And actually, I can call this the death rate. Maybe this will make it a little bit clearer. I'm going to click on the variable up here and click right on top of the births in that pipe. And let's call it the birth rate. And in this case, I'm going to go to f of x. One of my arguments or pet peeves is that we should always have running models. So I'm going to make this 100, and this is going to be people. And if I go to my birth rate, right now, I'm going to make this a function of something else, but let's go in with the units. This is going to be people per year. It's whatever is in the stock per time unit that I'm using. Got to make sure I go in and fix the time units in here. And I'm going to leave this blank. Let's see if I can just close this for now. And I'll go to my death rate. And because I've already selected it, I can go down and I have people per year. I know one thing that I'm missing. I had to redo this video because of it. If I go up to model and I go to settings, it's going to open this window and it's in months. And for now, I want it to be in years. And I'm comfortable starting out at 0 and going to 100. My time step should be much smaller. Typically, it should be 1/5 of the smallest time step in the model. Might be a little overkill, but I'll be fine there. I'm going to click OK. And now I'm going to add a few variables which are considered auxiliary variables. If you're using Stella, they might come out as converters. I'm going to click on here, and I'm just going to have a, let me call it initial, birth rate. And I know I'm going to be adding some additional variables, so I have the advantage of knowing where I'm going. And I'm going to type in here current birth rate. And I've got my variable still selected. I'm going to go over here and give folks in this an average lifespan. And now I'm going to go to my arrow, and I'm just going to connect a few things. So I'm going to go to my death rate. I'm going to go to my average lifespan, and click on deaths. So what I'm arguing here is for this rate equation, I'm going to have to do a calculation to figure out what my death rate is. My death rate is going to be a function of my population and my lifespan. And when we get back to this, it's simply going to be my population divided by, on average, how long people live. I'm going to go over on the left side here. I'm going to click on population again, go up and click and go to my birth rate. Takes people to make people in this case. And I know my initial birth rate is going to connect to my current birth rate. My current birth rate is going to connect to my birth rate. Now I'm ready to throw some equations in this. So if I go to the equation, my death rate I'd already mentioned is simply going to be my population divided by, whoops, don't have the division sign in there. I'll highlight that, population divided by my average lifespan. And click OK. I've got the units in there already. My average lifespan, let's say it's in the States or the EU. You give them 72 years. And the units are going to be years. Click OK. My birth rate is simply going to be my current birth rate times my population. It's going to tell me how many people are being born per year times my current population. I'll jump up to the initial. I know I want this to grow exponentially, so I'm going to put a number in here that's not real. I'm going to go with 0.1. Population is growing at 10%. And the units here are going to be dimensionless per year, right? So they're dimensionless per year. So this is the fraction. It's the average annual fractional growth rate is what we're really saying, right? A little high. And for now, I know I'm going to have other variables that are going to come into this later, but for now, let's just leave it at this. If I click on the current, I'm going to make current birth rate. I'm going to make it equal to my initial birth rate. And the units here are going to be dimensionless per year also. It's just equal to what's coming in, right? And at this point, I could simulate this model. So I'm going to run simulate, overwrite and exists. And what I'm anticipating is going to happen with a birth rate that high, this is just going to grow exponentially. This feedback loop here, if my population increases, my birth rate increases. If my birth rate increases, my population increases. And so now I have a stock. It's being changed by rates. So the flow variables. So the rates and the flows are interchangeable terms. And then I have an auxiliary variable here, which is only a function of one other. This is also, people will consider this an auxiliary variable. I like that. It's going to be a constant, meaning that it's going to have a value that's not going to change. And this is the same thing over here in the average lifespan. It's not going to change the way I've structured the model at this point. So I believe I've simulated this. If I click on a graph of this, that reinforcing loop is going to be growing. I'm getting exponential growth. So I'm going to click OK to close this. I want to add a few more variables. So I'm going to click on the variable. I'm going to have a carrying capacity. And while we're thinking of this, I'm going to go to f of x, click on carrying capacity. I'm going to make it 1,000. And this is going to be people. And it's capturing a lot of other things. This is a simplification, but the carrying capacity, how many people could I have if I was on an island or a small island? This is what could be sustained given the area of that island. I'm going to click on variable again, and I'm going to click on here. It's going to be the ratio of population to carrying capacity. And I'm going to add one more variable, which is going to be the effect of the population ratio on births. And those are the only variables I'm going to be adding to this. I'm going to click on the arrow. My population is going to be used to calculate the ratio of population to carrying capacity. Carrying capacity is going to be used to calculate the ratio of population to carrying capacity. There's an auxiliary variable. Let's go in and do that right now. If I click on f of x, it's a ratio, so I know I'm dividing one by the other, and I'm simply dividing my population divided by my carrying capacity. These two happen to be in units of people, so if I divide people by people, it's going to tell me my units are going to be dimensionless. So I'll be okay there. I'm going to click on the arrow. I'll connect it to the effect. I'm also just going to jump ahead and connect the effect to my current birth rate right now. I'll go back to f of x. And so this effect, it could be a nonlinear function, but what I'm going to do is make it linear. I'm going to say 1 minus the ratio. And what we should be doing now is thinking, what does this really say? If you've done anything in the environment, you know that this is the formulation for carrying capacity, or it's part of the formulation for carrying capacity. And what this is actually saying, we should always be thinking about this type of stuff. It's 1 minus the ratio. So what's the ratio doing? Starting out with 100 people, dividing it by that 1,000 people, so my ratio is 0.1. I've got 10% of the carrying capacity at the starting point. And if I take 1 minus that 10%, this is going to turn this into 0.9, right? So, and this is being used to calculate my current birth rate. So I'm taking that birth rate of 0.1, and now I'm multiplying it by the 0.9, so it's going to be smaller than that 0.1. So this is going to capture, as this ratio increases towards 1, this 1 minus the ratio is going to result in this number becoming smaller and smaller and smaller. And when it's 1 minus 1 is going to be 0. My birth rate would be 0. I would stop growing is what's occurring. Okay, and hopefully this makes sense. This is considered an auxiliary variable also. The only thing coming in is that ratio, and it's dimensionless, so this must be dimensionless. So I'm going to click OK. I'll go over to my current birth rate and click on that, and it's the initial birth rate times that effect. And it's dimensionless times dimensionless per year, so that turns out to be dimensionless per year. And now I can go in and simulate this one more time. I'll click yes. And my population is going to be S-shaped growth at this point. And there we go. It's growing exponentially at first. Let me make this bigger. It's growing exponentially at first, and it's reaching a tipping point, and it's moving towards this equilibrium state. And what's occurring in this is initially this feedback loop here is a positive feedback loop that's growing exponentially. And then this loop's kicking. This is approaching 1. This is 1 minus. So as this gets larger, this gets smaller. It's actually a minus sign here. So this balancing feedback loop is dominating later on. And I'm just going to go back and look at the population one more time. And you see it gets up towards 900, 850 or so. And it never gets to the 1,000, which is the carrying capacity. And stocks represent delays, and there's a delay. Folks are going to die before they're born. So there's always this, it's coming into equilibrium, but because of these two feedback loops, it's not quite reaching the population of 1,000. There's a steady state error is what that is called. So what we're really looking at here is this idea of what are the stocks? They're going to be the rectangles, they're accumulations in these systems. The only things that can change stocks are these flows that are going into or out of, or these rates in and out of the stocks. And that the auxiliary variables are all the other variables, and they can be broken into two. They're going to be auxiliary variables that you're actually calculating, and what I would refer to as constants. And the three auxiliary variables you're calculating are the ratio of population to carrying capacity, the effect of the population, ratio on births, and then the current birth rate. And then the constants are the initial birth rate, the average lifespan, and the carrying capacity. So hopefully this answers your question and doesn't confuse you too much. And again, keep the questions coming. So I will try to make videos to answer the questions if that's easier. And hopefully I'll get better at doing this, and hopefully they're useful. Thanks, and I will see you.